Improper integrals is the beginning of the rest of the course, meaning that it's very important and you should focus on it because you're going to use it many times later. So usually it looks like this. It's between a constant and infinity. There's a f of prime of x here because you will find the integral. And usually we change infinity to t for simplicity. And then you replace and you find an answer. If the answer is infinity, we call this divergent. If it was not, if it was a constant, we will call it convergence. Constant here. Okay. Okay, so let's start with our first question. So 1 over x, we first find the integral. So the integral of 1 over x is simply ln x. So this will become ln x from t to 1. We change infinity to t. Alright? Here there's no need, but like later, it will be important. So now we replace. So first we replace t. So it's going to be ln t minus ln 1. So t is infinity, so this will be infinity, and ln 1 is simply 0, so the answer will be infinity. Which means this is divergence. For simplicity, I'll call divergent div and convergent con. Okay, so next question. The first thing I notice is that there's two parts in this integration, meaning that we have to use integration by parts. So u will be x and v prime will be e power x. The derivative of x is 1, while the integration of ex is simply ex. So I'll use integration and I'll leave this for later, these two. Okay, so the question first, uv prime, which is x e power x, is equal to uv, which is x ex, minus the integration of 1 times ex, which is ex. And the integration of ex is simply also ex, so x power ex minus ex. And now we apply the negative infinity to 0. So, first of all, 0 will give you 0, minus e power 0 is 1. So, this will give you negative 1. Next is minus negative infinity. So, negative infinity here, e power negative infinity is 0. So, 0 minus e power negative infinity again is also 0. So, 0 and negative 1 minus 0 is simply negative 1. And since this is a number, this is convergence. Alright, next question. Alright, before I start, I want to tell you that whenever you see negative infinity to infinity, you have to split, meaning that should be negative infinity to 0 plus 0 to infinity. Same thing, but we split. We do that because it's going to affect the answer. Okay, so let's start. We have 1 over 1 plus x squared on both. And then we find the integration. So the integration of 1 over 1 plus x squared is arc tangent. Okay, so arc tangent between negative infinity and 0 plus also arc tangent between 0 and infinity. So if you replace here, I will do. So arctangent of 0 is 0. Then minus arctangent of negative infinity. It will be negative 1.57, which is basically negative pi over 2. And since there's two negatives, we can just make it a positive. So the first part here is pi over 2. Alright, so plus arctangent between infinity and 0. So arctangent of infinity is pi over 2. And arctangent of 0 is 0. So pi over 2 plus pi over 2 is pi, and since this is a number, it is convergent. All right. So next question. All right. So this is simply a rule where if p is less than or equal to 1, it's going to be divergent. And if p is greater than 1, it's going to be convergent. So let's check this rule. So if we have 1 to infinity, 1 over x power negative 2, the integration of 1 over x negative 2 is, which is 2 plus 1 over 2 plus 1, which will be x power 3 over 3. Great. So now we replace 1 and infinity. So infinity will give you infinity over 3, which is simply infinity, minus 1 power 3 is 1, 1 over 3. So minus 1 over 3, which will give you infinity, which is divergent. So anything less than 1 is divergent. Now let's try 2. The integration of 1 over x power 2, we take x power 2 to the top, it's going to be x power negative 2, and then plus 1 over the whole thing, negative 2 plus 1, which will give you x power negative 1 over negative 1, or 1 negative 1 over x. Great. So let's replace. So we replace here by 1 and infinity. So first of all, we're going to replace infinity, which will give you negative 1 over infinity, which is 0, minus 1. So minus minus will become plus 1 over x, which is 1. So plus 1, 0 plus 1 is 1, which is convergent. So this approves the rule. All right. So next question. All right. So the first thing I notice is that if we replace x here by 2, it's going to give us 0, which is undefined. 1 over 0 is undefined. So what I'll do is I'll take 2 as a. So I'm going to place 2 here by a. So a is equal to 2. So it's going to be, you have to write limit. Okay, limit a is 2. So basically you place 2 by a. Okay, so now we continue more. So we find the integration of x, radical x minus 2. Okay, so what I'll do is I'll take q as x minus 2, and du will equal dx because x will be 1. So this will be, I'll leave this till the end. So 1 over radical u times dx. So find the integration of 1 over radical u, which is basically, if you take it to the top, it's going to be u power negative half. So negative half plus 1 over negative half plus 1, which is basically u power half over half, or 2 radical u. Great. So now we have 2 radical u between a and 5. All right. Don't forget to change u to what it was. So u is x minus 2. Great. So when we have x, now we replace. Okay. So 2 radical x minus 2. So first 5. This will give us 2 power 3. 2 radical 3. Minus a, which is a is 2. So 2 minus 2 is 0. 0 times 2 is 0. So the answer is 2 radical 3, which is convergent. Next question. All right, so same thing. We find the integration of secant x, and then we replace by 0 and pi over 2. So the integration of secant x is ln secant x plus tan x. So ln secant x plus tan x. All right, and then now we replace. Okay, what's interesting here is that if you replace pi over 2 directly, you're going to find math error. So what we'll do is replace each alone. So I'll replace secant x, and if we put pi over 2, you're also going to find math error. So what I'll do is I'll put something close to pi over 2, which is 1.57. So 1.57 will give you a big number. So this will give you ln infinity plus. So whenever it's a big number, it's infinity. put tan and replace x by 1.57, it's also going to give you a big number, so it's also infinity. So ln infinity plus infinity is simply infinity. And now 0. So minus. If you put 0 in secant x, it's going to give you 1. So ln 1 plus tan 0 is 0. So basically ln 1 is 0. So minus 0. This will give you infinity, which is divergent. All right, so next question. Okay, the first thing I notice is that if I replace 0 or 3, I won't have an undefined answer. But remember, this is between 0 and 3, so there are numbers between them. And if you replace 1, you'll have an undefined answer, since 1 minus 1 is 0, and 1 over 0 is undefined. So what I'm going to do is I'm going to split them. So limit a is going to 1. This one is going to the left, because it's going to be from 0 to 1, which is less than 1. Okay? So 1 over 1 x minus 1. And the other one is limit a is going to 1 to the right, since 1 to 3 is greater than 1. 1 over x minus 1. Great. So now just apply the rule. So find the derivative, the integral, which is I'll take u as x minus 1. It's going to be 1 over u. And integral of 1 over u is ln u, which is ln x minus 1. Great. So we have this ln x minus 1 between 0 and 1. And we have this one also ln x minus 1 between 1 and 3. But this 1, or I should replace it by a actually. Got to replace it by a. So a, and a. So this a right here is from the left, 1 from the left. And this one is 1 from the right. So we should remember that when we're replacing. So ln x minus 1, x is a here. So ln a minus 1, since 1 is from the left, it's going to be negative. So this is negative infinity. Okay. As for this one, if you replace by 0, by the way, it's going to be 0. So ln x minus 1, we replace 3 first. So ln 3 minus 1 is 2. So ln 2, and then minus ln a, which is ln a minus 1, is infinity, since 1 is from the right. And we have infinity and negative infinity. So either ways, it's divergence. All right, last question. Okay, so ln x between 0 and 1. So I should find the integral first. I cannot find the integral of ln x. So what I'll do is I'll multiply by 1 and apply the integration by parts, which is u is equal to ln x, while v prime is equal to 1. And the derivative of ln x is basically 1 over x, and the integral of 1 is x. So apply the rule, which is uv prime, the question, ln x. I'll keep 0 to 1 at the end, equal to uv x ln x minus x over 1x, which is 1. And the integral of 1 is basically x. So now we replace between 0 and 1. 1 times ln 1 is 0, so 0 minus 1, so this will be negative 1. Minus 0, 0, minus 0 is 0, so minus 0. So the answer is negative 1, which is convergent. And that's it.